Hi guys, so in this lecture we'll be starting off with uh, some more examples on the resonating structures. So let us draw the resonating structure for this compound. Now this oxygen atom actually has two lone pairs. So let me redraw it. Yeah. The oxygen atom has two lone pairs, right? Because of its p orbitals, right? Okay, so now this lone pair actually comes here and this double bond shifts this carbon, so we would have something like negative charge here and oxygen gets a positive charge and a CS3. Okay, so we also got a double bond here. Okay, so you can draw the resonance hybrid of this compound as that this has a partial positive bomb positive, this has a partial negative and a double bond between these two carbon atoms, oxygen atom and oxygen carbon atom and carbon carbon atom. Okay, let us look at it. Let us look into second example. We have something like this. So again, as you know that nitrogen has a lone pair, so this lone pair will come to form bond between this nitrogen atom and the carbon atom, and the bond electron between this carbon and carbon atom would be taken back by this carbon atom. So we'll get something like this double bond between and a CS3 group. Okay, let us draw for this. Obviously you know that chlorine also has in fact 3 lone pairs. Now what it will do is it will push the lone pair between the bond between carbon and chlorine atom to get to this structure, and obviously the electron will be taken back by this carbon atom to get a negative charge on itself, and chlorine gets a positive charge. Okay, now let's look into this example. We have this compound and oxygen has a lone pair. It will give to this the form of bond between this carbon atom, and this carbon atom takes back the electron between the carbon carbon atom, so oxygen gets a positive charge with the double bond between oxygen itself and the carbon atom, and we'll get this resonating structure. Okay, what about the structure? We have NH2 group attached here and NO2 group attached here. So what would happen here is, as you know that N has lone pair with itself, so it will give it to the carbon atom to form a bond between itself and the carbon atom, and this bond electron will be taken back by the carbon atom on which NO2 is attached, so it will have a negative charge, NO2 attached, double bond with NH2 and gets a positive charge. We have the double bonds intact. Now this carbon atom will push the electrons onto this carbon to form bond between these two carbon atoms, and the para position carbon atom will take back its electron. We would have something like this. Now again the same procedure goes to result in a compound similar to this. Okay, now we have something like this. So what would happen? Here is NH2 attached, here is double bond, all the three bonds attached. So again we get the same structure. Okay, so you can easily draw the resonance hybrid of this structure. So let us move forward. We have something like this. So what would be the resonating structure for this compound? Again, just for practicing sake, I guess by now you would have gotten the complete clarity of it. I am again drawing the resonating structure for this resonance hybrid, I beg your pardon. Half and these two carbon atoms share the double bonds. Let us look into this example. So what would happen here is, this carbon atom takes back its bonded electron atom, and it again contributes to the electron pi bond conjugation. Okay, I am leaving this resonating structures to be completed by you guys. Okay, so we had enough practice of drawing resonating structures, and now we'll be moving on to the third case, wherein we will discuss double bond conjugation with free radical. Double bond conjugation with free radical. Okay, so let's say we have a free radical carbon containing organic compound with free radical on this carbon. So what would happen is, this free radical, okay, so what would internally happen is, we have a bond between this carbon atom and this carbon atom. The bond will break homolytically so that each carbon atom has one free radical on itself, or one electron on itself, right? And what would happen is, this free radical and this free radical, the free radicals between this carbon atom and this carbon atom will join together to form a bond between these two carbon atoms, and this would result in the formation of this type of free radical with a free radical on this carbon instead of the previous carbon. So this would result in the formation of a free radical containing organic compound, like something like this. So what we can say, that this pi bond actually comes and rescue okay, so a half arrow means only one electron is shifting. So this is the example of resonating structures wherein we have double bond conjugation with free radicals. Okay, so then let's now look at some more examples of third case. We have something like this. So what would happen is, this free radical with a half arrow indicating that only one electron is actually transferring to create a bond between this carbon atom and this carbon atom and this carbon atom. So what would happen is, in the resonating structure, what would happen? We would have something like, and this pi bond will actually break into creating a free radical at this carbon atom, this one. Okay, so let's create the first resonating structure. We have CH2 here, free radical over this carbon atom, and double bonds here. So what would happen next? Yes, you guessed correctly. This radical move on between to create a double bond between this carbon atom and this carbon atom, and this pi bond will actually break into free radicals, creating a free electron on this carbon atom. So we would have structures something similar to this. Again, what would happen is, this would be the organic compound from where we started making the resonating structures. Okay, now let us discuss about the fourth case. Where we have double bond conjugation with double bond. So double bond conjugation with double bond. Okay, so let's start with, it's simply saying that electron density shifts to more electronegative element. So you'll understand with the help of an example. So suppose we have a compound like this. So you know, O is the most electronegative element in this compound. So what will happen is, oxygen atom will withdraw its electron from carbon atom with the help of this bond. Okay, so what will happen is, we would have something like a plus sign on carbon atom with a negative sign on oxygen atom. Okay, why? Because the bond between carbon and oxygen atom, the electrons are being withdrawn by the oxygen atom, right? So now what will happen, as you know that the double bond conjugation with positive charge, so this double bond will move into between these two carbon atoms, creating a positive charge on this carbon atom. So what will happen is, this carbon atom will have a positive charge. This will create a double bond between this carbon atom and this carbon atom, and it would result in this compound. Okay, so in the next lecture we'll be seeing some more examples on case 4, and we'll deal with some more cases of resonating structures. Okay.